All right, welcome everyone to our philosophy colloquium. Today's speaker is from just up the highway at Gustavus Adolphus College. It's 12 miles. Hello, his name is Joshua Brown. His bachelor's degree is from Carleton College, although he is not a Minnesotan, but I still think he can be quite bright despite that. His PhD is from the University of Michigan. He taught for 2 years at the, 4 years at the University of Houston, prior to leaving the University of Houston for Gustavus up the road. His work is in philosophy of science, philosophy of language, and metaphysics. His talk today is titled Natural Objects. So please join me in welcoming Joshua Brown.
So I'm at least spiritually a Minnesotan. When I left Minnesota after college, I spent some time on the East Coast, and one January I was walking down the middle of the road, and I thought, oh crap, I'm a Midwesterner. And I hightailed it back to the Midwest, so I'm happy to be back here. So thanks for having me. So my talk today is about mereology, the study of the relationship between parts and the wholes that they make up. So molecules are composed of atoms. Atoms are composed of protons, neutrons, electrons. Tables are composed of tops, legs, miscellaneous bits of hardware. I'm a composite object too. I've got a head, arms, legs, various organs. Those organs are made up of cells. The cells are back to molecules, atoms, protons, neutrons, electrons, and so on. But not just any random collection of objects get together to compose some other object. So for example, you can't take my cat, Blixa, and get him together with the Eiffel Tower and have another object, right? Blixa and the Eiffel Tower don't compose. There is no Blixa Eiffel. No object that has Blixa and the Eiffel Tower as its parts. At any rate, this is what common sense tells us. But these common sense judgments, about what kinds of composite objects there are, and so what kinds of objects, when you get them together, make up another object. These common sense judgments invite what Peter Van Inwagen has called the special composition question. And this is SCQ on your handout. Under what conditions does a collection of objects compose another object? So what makes it the case that you get all the pieces of this table together in just the right way, and you've got a table, but even if you take my cat Blixa and you duct tape him, or worse yet, staple him to the Eiffel Tower, you don't get something new, right? So I'm going to call the answers to SCQ that respect common sense. I'm going to call them particularist answers just because I need a handy phrase for them. And they're going to deliver what mereologists call restricted composition. Some, but not all, collections of objects compose. The trouble is that finding the right account of restricted composition, the right particularist answer, is hard, maybe even impossible. Right? The account has to deliver the right composite objects, yes to tables and to me, no to the Blixa Eiffel. And it can't be circular, it can't be question-begging. That is, we can't, in giving the answer to the special composition question, we can't already assume that there are composite objects. So we can't say, for example, well, look, this group of objects composes just in case there's some object they compose, right? That's a completely uninformative answer. So the account also ought not be arbitrary. That is, we shouldn't just list the kinds of composite objects there are and say, whenever a group of objects makes up one of those things, that's the general answer. So we can't just say, look, a collection of objects composes just in case it's the parts of a chair, or it's the parts of an atom, or it's the parts of Josh, or so on. Right? Again, we have a completely uninformative answer. We want our account of composition to say why these composite objects and not others. Now, it turns out that answering the special composition is so hard that a lot of philosophers have despaired of ever finding an answer to it. And given that, they endorse one of either two extreme answers. According to the mereological nihilist, objects never compose. There's no Blix-Eiffel, but there aren't any tables either. Now, it gets worse. You're a composite object if you're an object. According to the mereological nihilist, you don't exist. Now, there aren't many mereological nihilists, but they're out there. Actually, plausibly, Leibniz was a mereological nihilist. The other extreme answer is mereological universalism. According to the mereological universalist, objects always compose. There are tables, but there's also a Blix-Eiffel. So your judgment that there is no Blix-Eiffel, that judgment's mistaken. Right? Get any collection of particles together you want, there's some object that they make up. But since both of these positions, mereological nihilism, mereological universalism, admit the existence of Blix-Eiffels or deny the existence of tables and chairs and you, they're error theories, right? They make us massively wrong about what the world is like. I don't like error theories. I would like to find some way to not have to be a mereological universalist or nihilist. So, in what follows, I'm going to present some work towards an account of, big qualifier right here, something like restricted composition. And it's going to take the form of the theory of natural objects. And there are really kind of two parts to this. And I'm not going to try real hard in this talk to separate the two parts. First, a framework for thinking about what sorts of objects there are. In particular, what sorts of composite objects there are. And this is kind of the basic theory of natural objects. And whether you're a universalist, a nihilist, a particularist, you can accept the basic theory of natural objects, and I'll show you how to cash out your position within that framework. Now, the basic theory is going to rely on some minimal claims about objects and properties and natural laws, but it's going to leave a lot of important questions about these issues open, and it doesn't by itself settle those mereological questions. So second, I'm going to attempt within the framework to answer those mereological questions. And this extended theory of natural objects is the account of proposition, or composition proper that I'm going to give. And the extended theory is going to rest on more substantive assumptions about the nature of laws, properties, individuals, and I'm actually mostly not going to defend those. The argument for them is basically, look, it lets us be particularists about composition, right? So it gets us what we want, and that's a good reason enough to adopt the framework. Okay, so answers to the special composition question are going to have the form SC there on your handout, right? There is a Y such that the X's compose Y if and only if blank, where we have to fill in the right-hand side of the biconditional. That's going to specify a condition on the X's. Now, I actually don't want to start there. I think that's a mug's game. That's the problem that's too hard. I want to start out by considering the special composition question from a slightly different perspective. Instead of considering what it is for some things to be parts of one another, I want to first consider what it takes for there to be an object in the first place, or at least an object of a certain metaphysical grade. So I'm going to look, instead of trying to look for an answer that fills in the right-hand side, I want to start by looking for a condition connected to there is a Y such that part. So I'm gonna tell a general story about objects. Now, we can't rest with such an answer because that's just going to beg the question about the nihilist, the person who thinks that there just aren't any composite objects at all. Okay, now this framework I'm going to sketch out, I'm going to make heavy-duty use of some metaphysical machinery from David Lewis. In particular, his theory of natural properties. And so we're now on to the preliminary section, and to do this, I'm going to give you a quick primer on Lewis's theory of possible worlds and his theory of properties. So here's what Lewis thinks. So consider the sentence Josh, and I guess there are multiple Joshes in this room, so we'll say me, Josh B could have been wearing a bear suit. Right? I didn't have to be wearing jeans and a suit jacket today. I could have worn a bear costume. Turns out that possibility isn't all that far away. I actually own a bear costume, right? And so it would have been weird, but I could have worn it, right? So it's a general problem in metaphysics to give an account of exactly what's going on when we make claims about possibility like this, right? We're making a claim about the way the world could have been. There are also claims about necessity, claims about ways the world has to be. So, for example, 2 plus 2 has to equal 4. 2 plus 2 couldn't have equaled 7, right? So here's Lewis's answer to this. When we make claims about what could be the case or what has to be the case, we're actually making claims about these certain kinds of objects called possible worlds. And a possible world is really a universe, a space-time whole, just like ours. So look around right now. You're looking at a possible world, okay? Now, he thinks that there are lots and lots of space-time holes, like this one, right? And so a world is just, well, this is the paradigmatic example of a world, right? Space-time plus all its occupants. And we've got a whole bunch of them. These are a bunch of occupants, and that's going to become important in a moment. Okay. Now, importantly, these worlds are not, often when cosmologists over in the physics department talk about other universes or other dimensions or other galaxies, they're not talking about things like this, right? Because they're generally talking about things that we have some sort of spatio-temporal connection to, right? Things that are actually a part of our space-time. They might be really, really far away, but if we could just travel fast enough, even though the laws of physics tells us we can't, we could get there. Lewisian possible worlds don't work like that. These possible worlds are completely and utterly spatio-temporally isolated from each other, right? You cannot get from one to another. They don't causally interact. In fact, they're isolated in every way that you can possibly conceive of. Okay? They're completely distinct entities. So, some more facts about it. The worlds are plenitudinous, and by that, Lewis means that, look, any way this world could be is a way some world is. And any way some world is a way this world could be. How does that cash out? Well, we need one more bit of the puzzle here. Importantly, for Lewis, individuals, objects, and worlds are limited to single worlds. Objects are world-bound. So you're only in one world, right? If you were in two worlds, you'd have to be in two places at once, because no place in any other world is the same as any place in this world, right? Because they're completely separate spacetimes. Since you can't be in two places at once, you can only be in one world, right? But here's the thing. So let's say this is our world. And we usually give it a little @ sign. In some of these other possible worlds, there are objects that are very much like you. They are your counterparts. I've got a counterpart. Say in this world right here, maybe we'll call this world 75, right? And when I say, Josh could have been wearing a bear suit, or I could have been wearing a bear suit. What makes that true is that there's a world out there where my counterpart in that world is wearing a bear suit. Right? So this is a world, world 75 is a world actually that's just like this one, except instead of pulling on a sport coat, I pulled on my bear suit. Okay, so, now you might think there's something special about the actual world, right? Here's what Lewis says is special about the actual world. You're at it, right? What's special about the actual world is really just what's special about here. There's no deep metaphysical difference between here, where you are, you're here, right? But that's not some deep metaphysical fact about here. Here just picks out whatever your current spatial location is, right? Go somewhere else and there becomes here. Right? When you go home, you say, I'm here. Turns out home is here rather than MSU. Well, when we say actual or real, in saying the actual world or the real world, actual or real just works like the word here does. All that's happening is we're picking out the world that we are at. All right, so much for the possible worlds. Now, I don't actually care so much about the possible worlds aspect of this, and I'm actually willing to jettison a whole lot of Lewis's substantive commitments. I'm not really committed to this being the right analysis of possibility and necessity. I'm not committed to these being concrete entities just like ours, and so on. I think this is a handy bit of technology, it turns out, for talking about what kinds of objects exist. What I really care about is Lewis's notion of properties that he overlays on top of this picture about possible worlds. So here's what Lewis thinks a property is. Lewis says a property is just any collection of objects, possibly cross-world collection of objects. Here's one property, right? There's a property. The property that just those three objects in the actual world has. There's a property that we all share. It's the property of being a person in, what's the name of this building? Armstrong 306, right? That's a property that we all share, and it's a world-bound property, right? Nothing in any other world has that property. But there are also cross-world properties. There's a cross-world property. Presumably, the property of being a person is a cross-world property. Why? Well, go to this world. That's the world where I'm wearing a bear suit, right? I'm still a person in that world. My counterpart better have the person property in that world, right? And so being a person, that's a cross-world property. Okay, now, really important thing about the property, properties are abundant. Take any collection of objects, and it's a property. Now, that means there are a whole lot of properties, because there are a whole lot of possible worlds. And each possible world contains a whole lot of individuals. And any way of dividing all of those individuals across all of the possible worlds into collections gives you a property. So if we just rested there, properties wouldn't be terribly useful. Because it turns out that, for example, my mug and I share nearly innumerable many properties, right? And we expect properties to do certain sorts of work. Like, look, I'm a really different sort of thing than my mug. And what makes me a different sort of thing is a difference in properties. But on Lewis's picture of what a property is, we share so many properties that it's hard to see how Lewisian property theory can explain the difference between me and my wife. So Lewis says, look, it turns out that properties come in different kinds of grades. We can order the properties by naturalness. Some properties are more natural than others. And in fact, some properties are perfectly natural. We're going to spend some time thinking about what that means. And unlike the properties, which are abundant, the perfectly natural properties are sparse. There aren't very many of them. Not every collection of objects is a perfectly natural property. So the collection of all the persons, that's probably a fairly natural property. But the collection that includes Blixa and the Eiffel Tower, probably not a very natural property at all. Here's what natural properties do. They ground relations of objective similarity, they ground causal relations, and they form a part of the minimal basis for characterizing a world. So if you want to say what a world is like in as few words as possible, you're going to talk about the perfectly natural properties. Now we identify natural properties through the roles that they play in natural laws. So for example, we know that mass plays a role in the natural laws, right? Force equals mass times acceleration. It's one of the basic laws of physics. Yeah. That was about the basic part. And that allows us to identify mass as a natural property. Laws, like properties, are more or less natural. So the laws of fundamental physics, whatever the right fundamental physics is, presumably those are the perfectly natural laws. Higher level physical laws, less natural. Laws of chemistry, less natural. Laws of biology, less natural than that. Laws of psychology, if there are any. Laws of sociology and anthropology, if there are any. Laws of political science. We go on and up the hierarchy of naturalness. And so the perfectly natural properties are the properties that end up getting treated by the perfectly natural laws. Now, this is just a sketch of the Lewis position, okay? And I'm not going to defend the Lewis position. I'm just going to put it to work. So I'm going to take all of this to be perfectly good and in order. All right, so here's the thing. I think we can make progress on the special composition question by extending Lewis's notion of naturalness from properties to objects. So some objects are more natural than others, and some objects are perfectly natural. So naturalness, this hierarchy of naturalness isn't restricted to a hierarchy of properties. It's restricted to a hierarchy of, or it's expanded to a hierarchy of objects as well. So that raises kind of the first question, which is, all right, what makes an object perfectly natural? We've got an answer about what makes a property perfectly natural. It's a property that, as it were, kind of makes the fundamental laws of the universe go. Right? It's treated by the absolutely fundamental laws of the universe. So here are some possible answers to when an object is perfectly natural. Answer one, an object is perfectly natural just in case different perfectly natural properties are instantiated on either side of its spatiotemporal boundaries. What do I have in mind? Well, look, I'm touching the lectern. What makes me, for example, a perfectly natural object? Assuming for the sake of argument I am one. It's that look, right there where I'm connecting with the lectern, there's a shift in which properties are instantiated. And Lewis doesn't think about perfectly natural objects, but there's another context in which he gives something that suggests this answer. Now, here's the problem with this answer. It seems possible for two distinct perfectly natural objects of the same type two persons, say, to share their perfectly natural properties, to be two objects that share their perfectly natural properties to be spatiotemporally contiguous, right? So I touch, suppose persons are perfectly natural, I'm touching another person. Well, now we've got the same perfectly natural properties instantiated on either side of the spatiotemporal boundary, right? And yet, we're still perfectly natural objects. Likewise, it seems possible, in fact, chemistry and physics tell us that it seems possible for two distinct perfectly natural objects to spatiotemporally overlap for parts or all of their lifetime. So for example, if electrons are perfectly natural, it turns out that two electrons in the ground state of a helium atom occupy the same space. But answer 1 rules out both of these possibilities, right? Natural objects overlapping, natural objects touching, and so answer 1's not a good answer. So maybe an object is perfectly natural just in case its unit class is a perfectly natural property. What do I mean by that? Well, remember, any collection of objects is a property, right? So that's a property. That property that's got one thing in it. That's a property, that's a property, that's a property. In fact, for each object, there's a property that only it has, the collection that's got just it in it, its unit class, or as I'll call it, its hexeity. So maybe to be a perfectly natural object is just to have a perfectly natural hexeity. Well, here's the objection to this. The perfectly natural properties are those that appear in the perfectly natural laws. So answer 2 amounts to this. An object is perfectly natural just in case its hexeity appears in the perfectly natural laws. The trouble is that the perfectly natural laws, in fact, all laws we hope, are general, right? There aren't laws that treat of being Josh. There might be laws about persons, but not about being this person, right? There are laws that treat of electrons, but not being this particular electron. And in any event, even if we do allow that some perfectly natural properties, maybe the hexeistic ones, can be instantiated without figuring in the laws, there's still no way to figure out which hexeities are the perfectly natural ones, right? And so answer 2's no good. I'm going to skip answer 3 for purposes of time. We can talk about it in the question and answer period if you'd like. Answer 4, an object is perfectly natural just in case it has only perfectly natural properties. This one I do want to talk about because this one fails for a really important reason. Remember the following fact about properties. They are abundant. They're superabundant. They're plenitudinous. Every single class of objects is a property. And so every object has infinitely, uncountably many properties. In fact, it has uncountably many perfectly non-natural properties. There are no objects that have only perfectly natural properties. Right? So if our criterion were that a perfectly natural object is one that just has those perfectly natural properties, there wouldn't be any perfectly natural properties at all. So here's the answer I am going to give. An object is perfectly natural just in case it has some perfectly natural property or other. Sorry, I want to keep up on the handout as well. And so that's listed actually both as the final answer on your handout and as the principal P and O. So consider what the perfectly natural properties are. They're the properties that appear in the perfectly natural laws of the world. Let's call that world W. And regulate its fundamental order, right? They're the laws that make the world go. If P is a perfectly natural property, then any object that has it at world W is directly subject to the perfectly natural laws of that world. That is, if an object's got a perfectly natural property of the world, it's the kind of object that those perfectly natural laws get a grip on. It's the kind of thing that the fundamental order of the world cares about. And so that seems to suggest that these are the objects you're looking for, right? Because these are the ones that, if you're trying to give a minimal account of what the world is like, they're the ones you're going to have to talk about. And so we have the principle P and O. And we can generalize P and O to less than perfect naturalness. So we define perfect naturalness by P and O, naturalness by P and O, and then we generalize it. And so to do this, I need an easy way to talk about this. And so we're going to let degrees of naturalness run from 0. These are the perfectly non-natural. To 1, the perfectly natural properties. So a perfectly natural object is one that's got degree of naturalness 1. All right? A perfectly non-natural object, maybe the Blix Eiffel, is just one that has degree of naturalness 0. And then there are the kind of the quasi-natural or the somewhat natural objects that presumably come in all sorts of different degrees of naturalness, just like the scientific laws do, and they fall somewhere in between. All right? And so we can define degrees of naturalness with NO star and NO. So an object O is degree N natural if and only if O has some degree N natural property. So if you've got any perfectly natural properties, you're perfectly natural. If you have any degree 0.5 natural properties, you are degree 0.5 natural. If you have any perfectly non-natural properties, you're also perfectly non-natural. Now, what this means is every object is perfectly non-natural, even the perfectly natural ones. And you might ask, that seems like a silly way to define naturalness of objects. It turns out that defining naturalness, degrees of naturalness this way, makes it much easier to state some of the principles we're going to talk about later. And so that's why we define naturalness this way. It turns out what we really care about is proper degrees of naturalness. So proper degrees of naturalness is given by NO on there. An object is properly degree N natural if and only if it's got some degree N natural property and has no properties that are of a more natural degree. So if your most natural property, that's about 0.25, is 0.25, right? And you've got a whole bunch of properties living on... Yes. And you've got a whole bunch of properties living on this side of the scale, and no properties living on that side of the scale, you are a properly 0.25 degree natural object. All right? I'm going to drop the talk about proper degrees, and you can just interpolate the proper into everything I say, because that's what we care about. All right. So, how are we going to use this to address the special composition question? Well, I want to consider what I'm calling the modified special composition question, which is MSCQ on your handout. Under what conditions does a collection of objects compose an object of degree N naturalness? Now, it turns out that this is really a question schema, right? We can ask this for every degree of naturalness. When do the objects compose a perfectly natural object? When do they compose a 0.63 degree natural object? When do they compose a perfectly non-natural object? And so on. And so the answers will have the form MSC on there. Now, it turns out that we can translate the standard mereological positions into this framework, and it's kind of cool, because it turns out that in this framework there are various different, different ways of formalizing the standard positions. There's a lot of nuance here. So for example, we might subscribe to hard nihilism. So remember, nihilism is outside of the framework is the thesis that objects never compose. There are no composite objects whatsoever. So hard nihilism is the thesis that no collection ever composes degree n natural objects for any degree n whatsoever. That is, there are no composite objects of any degree of naturalness. There are only mereological simples. And this, I think, is what most nihilists intend when they subscribe to mereological nihilism. But we can actually soften the nihilist position a little bit. So we might subscribe to no soft nihilism. No collection ever composes degree 1 natural objects. That is, maybe there are composite objects, it's just that none of them are perfectly natural. None of the composite objects play a role in the fundamental order of the world. There's also moderate nihilism. So no collection of objects ever composes a non-zero degree object. So there are composite objects, but they're all perfectly non-natural. And so we get the varieties of nihilism on here by saying where on here the composite objects, if there are any, would fall. The moderate nihilist says, look, there are such objects, but they all fall at 0. The hard nihilist says, there ain't no composite objects anywhere on the scale. The soft nihilist says, yeah, there are composite objects, they just don't fall there. We can do the same thing with universalism, with particularism. I want to highlight the soft universalism and the soft particularism, and it'll become clear why in a second. So soft universalism says every collection composes a degree n object for some n perhaps equal to 0. So we're saying that every collection composes, but it might be that whatever collection it composes falls at the 0 end of the naturalness scale. Soft particularism says some but not all collections compose degree n objects for n greater than 0. That is, there are some composite objects that live to the right of 0. So soft particularism is the denial of moderate nihilism. Van Inwagen has a weird view, according to which the only kinds of composite objects there are living beings. We can give Van Inwagen's view the same treatment. Now, not all of these views are mutually exclusive. I'm going to argue in what follows for an ultra-soft view. That is the combination of soft nihilism, soft universalism, and soft particularism. All right. So, how ought we answer the various instances of the modified special composition question? So let's start by thinking about the mereological simples, right? The things that have no parts. And ask ourselves the question, is every simple perfectly natural? Or are there some simple objects, objects that have no parts, that are less than perfectly natural? That is, does every thing with no parts live there? Or are there some things with no parts that live to the left of 1? So suppose that there's a world, and at this world we've got an object, a simple object, an object with no parts, and it's less than perfectly natural. So we need a name for it. Let's call the object Chuck, right? And Chuck is an atom, a mereological atom, and he lives right there at about 0.75. So Chuck's got some 0.75 degree properties, right? In fact, Chuck's got properties living on this entire part of the naturalness spectrum. He doesn't have any properties to the right of where he's located. So Chuck is being governed by the laws of this world, right? In particular, he's being governed by the 0.75 degree natural laws of this world. Those are pretty natural laws. Maybe those are like the laws of chemistry, right? So not the laws of fundamental physics, but the laws of chemical combination. So in particular, Chuck's not being governed by the laws of fundamental physics, at least not directly. All the work that the laws of fundamental physics are doing on Chuck, they're doing through their work kind of through the laws of chemical composition. So Chuck's governed by the laws, but not directly by the perfectly natural laws. And Chuck is a mereological simple. He doesn't have parts. So Chuck isn't governed by the laws of this world in virtue of his parts being governed by the perfectly natural laws of this world. So Chuck is in a way completely unconnected to these perfectly natural laws, right? The natural laws don't get a grip on Chuck by treating Chuck directly, and they don't get a grip on Chuck by treating Chuck's parts, because Chuck doesn't have any parts. But these perfectly natural laws, properties, and objects are supposed to provide the minimal basis we need for characterizing what's going on in this world. But if we can say everything about those laws, properties, and objects and not say anything at all about Chuck, then that list isn't minimal. Right? We've left Chuck out. Any adequate characterization of this world would have to include Chuck independently of everything that's perfectly natural. And that's a contradiction given how we've talked about naturalness. And so I think we ought to conclude with the principle perfect simplicity. Every mereological simple is perfectly natural. So what about the composite objects? How should we answer the modified special composition question most generally? So let's start with the principle NRC on there, NRC for naturally restricted composition, as much as I wish this research were funded by the National Research Council. So NRC says, look, the x's compose something, just in case there's a degree of, the x's compose something of degree n naturalness. Just in case there's some degree n property that the x's collectively have. It's not that the individual x's have it, it's that the collection of x's itself has it. Often in the mereological literature, an ideal like this gets imported with the locution being arranged f-wise for some f. So for example, here's a collective property of the parts of this table. They are arranged table-wise. So, the x's compose something of degree n, just in case they're arranged f-wise for some property f that figures in the degree n laws. And so the idea is that the degree n natural laws take notice not just of the individual x's, but of the entire collection. And they're treating the collection apart from just treating the individuals. So here's an example. Let the quantum mechanical laws be degree n sub 1 laws. And let the laws of chemical combination be degree n sub 2. And so it's plausible that the quantum mechanical laws are here somewhere. They're not the fundamental laws, right? But they're a lot more natural than the laws of chemical combination. All right? So, being arranged isobutane-wise is an N2 degree natural property, one that doesn't appear in the more natural laws of quantum mechanics, and can't, it turns out, be reduced to those laws in any way whatsoever. There's actually a fair bit of literature in philosophy of chemistry on this, whether or not you can reduce molecular shape to the laws of quantum mechanics, and it turns out the answer is no. Quantum mechanics does not deliver molecular shape at all. And yet, molecular shape is a really important property in the laws of chemical combination. So it turns out that being arranged isobutane-wise is not just a degree N1 property in disguise. Some collections of 4 carbon and 10 hydrogen atoms are arranged isobutane-wise. These collections compose isobutane molecules, which are degree N2 natural objects. So, isobutane molecules live somewhere there. Isobutane molecules are not perfectly natural objects. Now here's a big worry. This threatens to make the Blixen-Eiffel a very natural object, almost immediately, because the Blixen-Eiffel has mass. And mass is a pretty natural property. In fact, it turns out, I've been talking to a bunch of particle physicists. It's actually not clear to me that it's a perfectly natural property, but it's awfully close. This takes us to universalism almost immediately, right? Because just about any collection of objects is going to have mass, right? And so any collection is going to turn out to be perfectly natural on that. So here's the response. Look, it's not like the laws of physics treat the mass of the Blixen-Eiffel in addition to treating the mass of Blixa and the Eiffel Tower. In fact, if you look to plug the mass of the Blixen-Eiffel into your equations along with the mass of the Blixa and the Eiffel Tower, badness results, right? You get all sorts of wrong answers. Your airplanes won't take off, etc. So the laws don't treat the Blixen-Eiffel in addition to treating the Blixa and the Eiffel. In fact, what's going on is the Blixen-Eiffel having mass just is the Blixa and the Eiffel having mass. In fact, the Blixa having mass is just the Blixa's parts having mass, and so on. The Blixa inherits mass from its parts. As far as the laws are concerned, the Blixa-Eiffel, and in fact, the Blixa, might as well not be there. And so we can formalize this by insisting that whatever arrangement property we're talking about in NRC there is non-inherited. And that's the little caveat bit in there. What do I mean by inherited? Well, we can define inheritance as it's spelled out in that inheritance clause on your handout. Property F is inherited by the x's if and only if A. Some of the x's have property F, and it's a consequence of the laws that if some of the x's have F, then the x's collectively have F. Having mass, being material, and all of the other properties that threaten to take us immediately to hard universalism, as far as I can tell, are all inherited. All right, so let's take on board NRC with that caveat. So given that, are there any perfectly natural composite objects? So are there things that have parts that live right there? Right? Along with the mereological atoms. I see somebody shaking their head no, and I like that answer because that's where I want to end up too. So here's one argument that might be suggested if you're a fan of David Lewis, and actually the more I think have thought about this recently, I've decided that this is a terrible argument for other reasons, but here's the argument. The way that, if we stick to the way Lewis conceives of perfectly natural properties, it looks like no, the all the composite objects have to live to the left of 1 there. Because according to Lewis, perfectly natural properties are intrinsic properties. That is, they're objects that, well, they're properties that objects in a way have in and of themselves. They're completely non-relational. But the thing is, we're dealing here with collective properties, arrangement properties of the x's, and all of these are going to be extrinsic to each of the x's themselves, right? So all of these arrangement properties turn out to be extrinsic. Lewis says natural properties have to be intrinsic, and so the answer is no. It turns out that I'm starting to worry about defining intrinsic and extrinsic in Lewis's framework. So I don't know if this works. It turns out that even if we accept this argument, things aren't quite so straightforward. So consider gunk. In a gunky world, there aren't any mereological symbols, right? No objects that have no parts. Everything's composite. You just keep getting smaller and smaller and smaller, right? Now there are 2 ways to go here. We could allow for perfectly natural composite objects, which I don't want to do, or we could deny that gunky worlds have any perfectly natural objects at all. This is the option I favor, and it's probably not as crazy as it sounds. You might ask yourself, how could there be a world without any perfectly natural objects? But look, a gunky world is as good a candidate as any for being a world with no fundamental laws. Laws that treat perfectly natural properties, because there's no fundament. There's nothing for those laws to get a grip on. There aren't any fundamental objects in such a world, right? Now it turns out that there might be other ways to go here. We might think about gunky worlds as monistic worlds. That is, there's exactly one perfectly natural thing, the whole world, and as we carve it up into smaller bits and pieces, we get less and less natural, right? So that world, in that case, the fundamental laws of physics treat the world as a whole, and the less and less and less fundamental laws start to treat parts of it. That's another way to go. So put aside gunky worlds and monistic worlds, because I think we seem to have evidence that we don't live in a monistic world or in a gunky world. Here's the intuitive case against perfectly natural composite objects. Look, perfectly natural objects are metaphysically fundamental, but composite objects are never fundamental, monistic worlds aside, because composite objects are metaphysically dependent on their parts, right? So no composite object is perfectly natural. Soft mereological nihilism is true. Now, it would be nice if we didn't have to rely on this intuitive argument and could instead derive soft nihilism directly from NRC. And if anybody knows how to do that, I will be forever in your debt, and I will cite you copiously in this paper. But alas, I don't think we can do it. I would love you to prove me wrong. Consider a world containing a perfectly natural composite object. That is, we've got a composite object that lives there. We'll call him Quincy. Right? What that amounts to, according to NRC, is there are some perfectly natural x's, right? Quincy's got parts. We'll assume they're perfectly natural objects, right? And they're arranged f-wise. They're arranged kind of Quincy-wise. And being arranged Quincy-wise is a perfectly natural property, a property figuring in the perfectly natural laws. And since being arranged f-wise, Quincy-wise, is perfectly natural, being arranged Quincy-wise isn't reducible to or supervenient upon those other properties that Quincy's parts have, right? So we're in this weird situation where some collections have properties and are gripped by the laws completely and utterly independently of the properties of the members of that collection, right? So the perfectly natural laws are getting a grip on Quincy in 2 ways. One, by getting a grip on Quincy's parts, and two, by getting a grip on Quincy himself. And the two are completely unrelated. Now, this isn't inconsistent, I don't think. I wish it were. But it's not. It's bizarre. It's a world in which both collections and their members are fundamental. And so it's a world in which some mereological facts are emergent or brute. And there are fans of emergence out there. I think they're nuts. If we deny that these worlds are possible, we get soft nihilism, but I don't have any good argument that such worlds are impossible. And so I think the best position to adopt is a modest one, that brute worlds are possible, but until we have good evidence that our world is a brute world, we ought to presume that our world is a soft nihilistic one. And so we ought to accept what's on there called presumptive soft nihilism. I have about 5 minutes left, is that?
Sure.
Okay. All right. So, every mereological symbol is perfectly natural. Presumably, every actual composite object is less than perfectly natural. That is, the mereological symbols are all hanging out there. The non-mereological symbols are all hanging out here, right? Now, let's ask the question, does every collection of objects compose, right? We've said that all of the collections that do compose, the objects they compose are hanging out over here. But are there some objects that maybe don't compose anything at all? So is soft universalism true or false? Now, NRC, together with the principle that degree n properties figure in the degree n laws, suggests the following general composition principle, the GCP on there. The x's compose something, full stop, just in case there's a property f and a degree of naturalness n, such that the x's are arranged f-wise and f figures in the degree n natural laws, right? So the x's compose just in case there are some laws out there that govern some collective property of the x's. So GCP allows for degree n composite objects for all n greater than 0, right? But since there aren't any degree 0 laws, to be degree 0 is just to be completely unlaw governed. GCP rules out perfectly non-natural composite objects. So by GCP, there are no perfectly non-natural objects whatsoever. That is, 0 here is empty. Everything at all lives to the right of 0. Thus, so long as the natural laws of our world work out right, GCP delivers real restricted composition. If the laws are such that some collection is arranged f-wise, f figuring in the laws of our world at whatever level, there are composite objects. And if some collection has no arrangement figuring in the laws, then not every collection composes. Of course, it's a further step to argue that GCP delivers the right composite objects, delivers tables but not the Blixeifel, that step involves determining all of the laws of our world, even the laws of the minimally natural ones. So we don't need just complete physics, we need complete science. But I'm a philosopher, that's not my job. Now if we stop here, we've settled on hard particularism. Some collections don't compose anything, not even a perfectly non-natural object. And so we have restricted composition. I think there's actually a case, though, to be made for soft particularism. The view that, though not every collection composes a minimally natural object, those that don't do compose perfectly non-natural objects. So every collection composes, but not every collection composes an object of degree of naturalness greater than 0. That is, I want to give you an argument that there really are some objects living there, and that that's okay. It's meant to, that what I'm going to tell you is going to hopefully take the sting out of universalism. So partly this is I think that the universalist actually has some good arguments, right? And we can talk about how those work in question and answer period. But there's also this analogy between objects and properties. Every class of objects is a property, even if the class plays no role in the natural order of any world. Look, there are non-natural properties. Likewise, we might think every collection of objects composes, even if the composite object is a bystander to the natural order. And I think considerations of theoretical simplicity nudge us in this direction. It also makes available objects to serve as semantic values for putative names like the Blixen-Eiffel. If there is no Blixen-Eiffel, then how the hell can we talk about it? Well, if we allow non-natural objects, problem solved, right? There is such an object, it's just perfectly non-natural. Now, here's the payoff. I think that the theory of natural objects can help assuage some of the intuitive weirdness about bizarre composites like the Blixen-Eiffel. Universalism seems implausible in part because it insists that the Blixen-Eiffel is an object that is, in some sense, just as metaphysically good as a molecule of isobutane, or a tiger, or the Blixen. But we have a really strong intuition that the Blixen-Eiffel is metaphysically second-rate. It's superfluous. Whatever role it plays in the workings of the universe is really better played by its parts. Soft particularism, though it admits arbitrary composite, vindicates all of these intuitions. Perfectly non-natural objects, which most arbitrary composites are indeed very unlike isobutane molecules, cats, persons, and even tables. They are of a lower metaphysical grade. And they're nomoologically inert. The laws don't get a grip on them at all. They don't add anything to the order of the universe but themselves. So on this view, soft particularism, arbitrary composites are exactly as our intuition has them. But that's no reason to reject their existence. And so I want to endorse principle NC on there, which is like our NRC except it, or sorry, like GCP except it says anything that doesn't compose to the right of zero composes at zero. Now, you might wonder what the real difference is between an account on which arbitrary composites don't exist and one on which they exist but are perfectly non-natural. Bad news. I don't think that there's a whole lot that can be said. Why? Well, because I think saying it would require a good account of a good analysis of the concept existence, and I don't think that there's any good analysis to be had because I think that existence is a basic concept. And thus the difference between such objects not existing and them existing but being perfectly non-natural is just whether or not we scruple to quantify over them. Good news. This is exactly what we ought to expect and want of perfectly non-natural objects. The metaphysical space between being perfectly non-natural and not existing is infinitesimal. And indeed, this is what makes soft particularism a substitute for real restricted composition. Okay, I'm going to end there. Let me prime you with a question. How do we get tables and chairs out of this? You can ask about tables and chairs in question and answer period, but I'm out of time, so I want to stop.
I assume you'll field your own questions?
I can field my own questions, yes.
Please ask questions. You're all sitting in chairs, you might want to know if they're there or not.
All right, I got a question. Could you, it's not so much a question as a request, the derivation that you wished somebody would provide,
Yeah.
could you just maybe lay that out a bit, what it would give you and what you think might be involved, some pieces that that you might allow as premises, that kind of thing?
Yeah, so here's the derivation I want is this. I want NRC, right? This principle about naturally restricted composition. Really NC, right? Because that's what I end up endorsing. I want that to entail soft nihilism. So I would like the principles of composition to just give me the principle that every composite object is less than perfectly natural, right? So what I really want is I want a knockdown argument that there are no composite objects there. Why? Because it just seems ugly if there, the theory seems ugly, right, if there are composite objects there. I wish I knew what the derivation would take. So here's why I think there is no derivation. Because I can describe a case. I can describe a possible world where there are composite objects living right there, right? And so the case is just, all right, so we've got George and Bertha and Claire, and those are all perfectly natural objects, and they're symbols, right? And they've got this property, right? We know that they've got a property because every class of objects is a property, blah, 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 right? And call that property Q. And suppose that Q figures in the perfectly natural laws of this world, right? So we have this fundamental law. And in this fundamental law, we reference this collective property of George, Bertha, and Claire. That seems perfectly consistent to me, right? I don't see any contradiction in that world. And so that world looks possible. Well, here's the thing. Given the principle about composition that I've got there, whether you take it to be NRC or GCP or NC, right? What this tells me is that, well, George, Bertha, and Claire compose an object in virtue of having collective property Q. And they compose a perfectly natural object because Q is a perfectly natural property. And so what that gives us is, well, Quincy, this composite perfectly natural object. So the reason I think that there's not any argument from NRC to soft particularism is because I think I've got counterexamples worlds. And I would love I would love to be convinced that this is inconsistent, or I would love to be given some independently plausible, intuitive, some independently plausible principles about naturalness or laws or properties that rule out such a world. And so it might be that so there actually hasn't been, Lewis kind of gives us this sketch of what natural properties are supposed to be and uses it to do a bunch of work. But there hasn't been a whole lot of work on really fleshing out the notion of naturalness in detail. What we've got is kind of this hand-wavy, here's the work that naturalness is supposed to do for us, right? And so it might be that once I start thinking a lot harder about naturalness and try to generate some more plausible substantive principles about what naturalness really is like, there will be a principle that allows me to rule that out. But I don't have it yet. Other bit of evidence, there are people out there who argue for emergence. Not just that emergence is possible, but that it's actual. Yeah. I want him to be wrong, but I don't have an argument against it.
Right, you answered that. I can understand.
All right. And yeah, I wish for my sake it were a more satisfying answer, but.
What you said about existence being a basic concept?
Yes, I think existence is a basic concept. I don't think that there can't be any good or substantive analysis of existence. So I think giving, there's actually quite a large literature trying to give some sort of criterion for existence, right? And in a way, it often, these criteria are supposed to be, people present them as if they're supposed to be a priori knowable, right? Look, something exists if and only if it has causal powers, or whatever. And I just don't, I don't see any contradiction in denying, no, there can be things that exist that don't have any causal powers. We would never be able to know about them. Or maybe we would, right? Plato thinks we do, right? So I don't think, numbers don't have causal power, even the Platonists don't. So I just don't think that there can be any analysis. I think you could give arguments for that as a principle, but as an analysis of the concept of existence, I think it's a non-starter. I actually think I think Quine's criterion is to be the value of a variable is false. Yeah. In fact, I think it's conceptually confused. In fact. Yeah.
Now you're sort of relying on science to come up with the laws that are going to help you figure out which things are composite objects are natural or not. Now, it seems very frustrating, I would think, for you, because I'm not sure that science is anywhere near coming up with an account of what would be the laws that would explain actions and so forth.
Okay, so let's separate out two questions.
Can I squeeze one more in real quick? That's related.
Sure.
Okay. What I would say is, when you were talking about monism, I was thinking, Parmenides and I was thinking,
John, could you speak a little louder?
Parmenides has a real easy way of talking about the world, scientifically, yes? Got one predicate.
Right.
Everything added.
Right.
That's it.
Right.
And that's the one you said is fundamental. Yes. So
Yeah. So
if you're a scientist who says there's only one property we need to worry about, the only one thing that worries about our natural laws, that's the only one we worry about. It is.
Sure. Yeah. So I actually think that we could discover that monism is true. Now I actually think we have pretty good evidence that it's not. Why? Well, because I think that what science has revealed is the behavior of large things supervenes on the behavior of smaller things, not the other way around.
But it's at what level, right? Again, because then you get, if it is, it's always the only property, then you start to back away from.
Sure.
Yeah.
And ultimately maybe physics goes there, right? And so look, if the way to finally reconcile quantum mechanics and relativity is to go to some monistic, Parmenidean or Spinozist or, God forbid, Bradleyan kind of monism. I have a hard time imagining what a monistic physics would look like, but people had a hard time imagining what relativity would physics. But so I actually think that that's a possibility. And if it turns out that there is really only one fundamental object, the whole world, maybe that's right. Now in a way, there's a point at which it doesn't make a difference, and that's the middle level. Tables and chairs turn out to be kind of fairly non-natural, whether the most natural things are the really tiny things or the one big thing, right? our medium-sized world is living somewhere in there in any event. And so the question about whether modism is true or some kind of pointyism is true is just how big the objects are that live here at 1. Yeah. Yes?
What is a propertyless existent thing?
I don't think that, well, at least on this view of properties, right? There can't be any propertyless things.
Then why refuse Quine's conception of existence? Because precisely what it rules out as something that's, you see where this is going to go?
Sure.
I mean, it doesn't, if you agree, why not agree with him then?
Yeah, this is a completely separate commitments I've got. So why not agree with him? Because the following is a true sentence. There are things that don't exist. You asked me to prove that it's true to you. I can give you examples. Harry Potter. And so the standard line is, when you say there are things that don't exist, that's not what you're, I mean, the Quinean project is to paraphrase that. When we say Harry Potter doesn't exist, blah, blah, blah. But, you know, it doesn't work. There are no such paraphrases, right? And when I say...
I'm not sure about the right.
What's that?
I'm not sure about the right. You added that there are no such paraphrases, right? No, I'm not, it's not obvious to me that that's right. I think there may be such paraphrases. I mean, why not? Why can't we have a reductionist view of you know, fictional characters and all this, and index them to the fictional world?
Well, for one, okay, so we have to be careful, right? There's an actual unlimited paraphrase where there are no fictional characters, like, there ain't no Harry Potter. Harry Potter does not exist. And quite honestly, that's what, to rescue common sense, that's what we want. Because damn it, Harry Potter does not exist. It is literally true that there is no Harry Potter. And then there's the move that people like Van Inwagen make, which is, turns out there really are fictional characters. Harry Potter really doesn't, and that's kind of the move that you're making.
It's not my favorite move, but it's one move.
It's one move, but it's a crazy move.
I agree with you.
It's his Thursday night move.
I mean, well, and I have views like that. I'm a Thursday night content. So what's your favorite move?
To try to rescue the intuition that there are no such things as that.
Well, so when you say try to rescue the intuition, what do you mean?
I mean, well, this won't matter to most people, but I'll answer your question. I used to do a lot of aesthetics, and you probably know.
Yeah, sure.
Fictional, and I chaired a number of sessions on this, and I sat listening for hours on end and over dinner about you know, trying to show that it's reasonable to think fictional characters exist. Why? Because they were trying to rescue literature, because literature has various valuable functionality. And my intuitions don't run that way, because I'm a physicalist, I'm a materialist, I'm a nominalist, so yeah. I don't want anything to do with any of that.
Okay, so let me tell you how to do that. Deny Quine's criteria.
I thought he was going to save me.
No, because Quine says if you have to quantify over it, then you're committed to it existing. So if you have to quantify over fictional characters, you have to believe in them. And the trouble is, there's no good way to avoid quantifying over.
It's like the indispensability argument for numbers.
Yeah, that's exactly what it is. There's an indispensability argument for fictional characters. So that's the argument that Van Inwagen makes. He says, look, in aesthetic discourse, we gotta quantify over fictional characters, so you better believe in Harry Potter.
We need a book by Hartree Field, another one.
There's a
literature without fictional.
There's a great one.
Literature without characters.
It's called It's by Jody Azumi. Azzouni.
Physics without ontology?
That's his, yes. There's That's his most recent one. He's got 2 on this. I will email you the titles. But you know, he's the one who has this extended argument that, look, the problem here is that Quine's criterion is just wrong. Quine doesn't really have arguments for the criterion. Insofar as he has something that looks like arguments and that you can trump up into arguments, they're terrible arguments. And so and the criterion has clear counterexamples, like there are things that don't exist. Harry Potter, for instance, right? Yeah, just give up Quine's criterion. You don't like, I mean, it's got nothing behind it. Plus, it turns out, so on the one hand, so Jody thinks that that quantification is objectual. So your ordinary logic that you teach in quantifier logic class, yeah, that's what quantification really is. And Quine's wrong about that being ontologically committed.
That sounds excellent. We don't have domains of fictional things, right? That is, limit your domain to objects.
Right. So yeah, Jody thinks, look, you can include non-existent objects in your domain in a way that's completely non-Meinongian, and that's because he thinks that domains are just these weird, funny mathematical constructs that blah blah blah. So one thing to do is go the Jody route, deny that objectual quantification is ontologically committing, and I agree with that. I've actually also got this other view, so I agree with Jody, but I've got this other view that that objectual quantifiers are not actually the right quantifiers. And it's not substitutional, and it's not free quantifiers. It's something that Jim Garson has come up with called a natural quantifier. And it turns out those are not ontologically committing, even by Quine's lanes.
I don't know that Quine would necessarily disagree. I think he would say there are different domains or different areas of discussion or talk. And so, but when you get to the fundamental, best scientific language, then what's in that domain will be the final ontology.
Well, I mean, it's complicated. So there's, in a way, there's what Quine says and there's what Quine's entitled to. So Quine uses the criterion in all sorts of ways to deny that he himself has various commitments, say, to properties or universals, and to convict other people of ontological commitments to numbers, say. And then you get students of his, like Van Inwagen, who thinks that, look, if you're going to take the criterion seriously, it gets you fictional objects, fictional characters. David Lewis, who thinks it gets you concrete possible worlds, right? Now, Quine's also got kind of this other commitment, his holism, right, and his naturalism. And he says, look, our one serious conceptual scheme is the conceptual scheme of science. Now, here's an important thing. The conceptual scheme of science, not necessarily fundamental science, though at one point he says, look, physics is the thing that aspires to blah, blah, blah. It turns out that that's actually, he's being a lousy naturalist there. And whenever Quine encounters an entity he doesn't like, and he can't paraphrase away, he says, maybe it won't show up in our final science.
Exactly.
But of course,
he's like you when you said you're waiting on the laws of science. He's sort of waiting.
except he can't do that with his criterion because he thinks, for example, that if you say, look, I'm awaiting a number-free version of fundamental science, or I'm awaiting a fictional entity-free discourse aesthetic discourse, he's going to say, no, you can't do that. You're committed to those entities until you can actually hand me the paraphrase. And so Quine himself isn't entitled to that mood. And I actually think that, like, the hand wavy, someday we'll be able to paraphrase it, that's kind of a chump move.
Well, on science, that's all. You just wait on what the scientists come up with. And if they do get rid of numbers and, in science, he's happy to use the numbers.
Oh, that's right, but of course he argues that they're never going to, right? Yeah, I mean, better to just ditch the criterion, quite honestly. Because, no, seriously, because it's transparently false. There are things that don't exist. If Quine was right about there are, meaning exists, not only wouldn't that sentence be true, that sentence would sound like a contradiction to us. It would sound like P and not P. There are things that don't exist. It doesn't sound like a contradiction. It sounds perfectly true.
All right, so, thank you.
I always love talking about Quine. Thank you for bringing that up.
Yeah. Yeah. Perfect. Thank you.
It was a joy to
I think probably just by looking around and looking at the numbers. Yeah.
Take some with you,
My lamp.
because you'll get thrown out otherwise. So it turns out there wasn't much of a connection.
Give me your last name.
But I mean, at some level there is maybe. It's just,
It's still philosophy.
yeah. It's connected somehow.